Okay, now we're going to talk about compound inequalities. You'll see that they're compound inequalities because they have more than one inequality in the statement. For example, right here, this one's got a less than and another less than. This one over here has got a less than in this inequality and a less than in this inequality. This is called an OR statement. This one over here, when they're built into one statement, is called an AND statement. It's a conjunction. OR statements are disjunctions. All right, so we're going to learn how to solve these. It's pretty similar to solving an inequality. On this one right here, you're going to make sure that you just solve each one, but instead of having to separate them, you're going to start in the middle and go out. So I'm going to close this in, and I'm going to say, okay, what do I need to get that x all by itself? Well, I've got a positive 3 here. I'm going to do a minus 3. Whatever I do to the middle, I have to do to the right side. Then I have to do to the left side. Okay, then I'm going to just -5 and a -3. Both of them are negative. Add them, keep the sign. The less than sign comes down. 2x left here. The 3's go away because 3 plus a -3 is a 0. 15 minus 3 is 12. Okay, then I'm going to go back to the middle and I'm going to do my divide. I'm going to divide by 2 here. Then I'm going to divide the right side by 2 and the left side by 2. Since I'm dividing by a positive, I don't ding, 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 flip that thing. I just bring it on down. Anytime you are going to flip the inequality, you would flip both inequalities. Okay, so here we go. This gives me my x in the middle, and that's what I'm trying to do, is get the x all by itself in the middle. Over on the right side, 12 divided by 2 is 6. -8 divided by 2 is a -4. Okay, so this is my answer to my conjunction, my AND. And the way you say this is all numbers between -4 and 6. Okay, but it's not including -4 or 6 because they're less thans. If they were less than or equal to, they would include -4 and 6. Okay, so how do you graph it? Well, I'm going to put a 0 here. My -4 is somewhere over on this side. My 6 is over here. Both of them get open circles because they're just less thans. And then in between is everything in between the numbers. They come together. Okay, let's go over here and look at number 6. This is an example of a disjunction or statement. Okay, so what I'm going to do is I'm going to go x plus 7 is less than 4. I don't know why I just wrote that down again. All I have to do is subtract 7 from both sides right here. And I get x is less than 4 minus 7. They're different signs, so I'm going to subtract them, keep the sign of the bigger one, which is 7. So I'm working one problem at a time. If you start with an OR, you're going to end up with an OR. Okay, you start with an OR, you're going to end up with an OR. All right, so over here, I'm going to subtract my 7. These are two different inequalities. Okay. Keep my less than, got a -x. 1 minus 7 is a subtractum. It's a 6. It's a -6. I have that negative sign sitting right out on the outside here, so I'm going to have to divide by negative. So I'm going to ding, 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 flip that thing. Divide by -1 right there. So here I'm going to get my x. Over here, negative over negative is a positive, and 6 over 1 is 6. Okay, so how do I graph it? Put your 0 down. You've got a -3 over here. Put it right here. And it's an open dot because it's a less than. Got a 6 right here. Open dot because it's a greater than. Now, ORs usually don't come together. So this one, you're going greater, everything greater than 6. And this is everything less than negative 3. So ORs don't come together. All right, let's go look at number 7. All right, you notice that this is an AND because I've got two inequalities right there. I've also got a parenthesis. So what am I going to do? I'm going to distribute this negative sign, which is considered as a negative 1, to the inside the parentheses. So negative 1 times x is a negative 1x. You don't have to put the negative 1. Negative 1 times a negative 1 is a positive 1. I'm going to go ahead and just bring down my inequalities just like they're written because I didn't divide by or multiply by a negative across the inequality. All right, so then I'm going to go in between again, and I'm going to get rid of the positive 1. So I have to do it to all three sides. I'm just subtracting 1, so I do not flip the inequality. So negative 4 and negative 1 gives me a negative 5. Bring down your less than or equal to. Inside I have a negative 1x. Drop down the less than sign. 4 minus 1 is a positive 3. Okay, I've got to get rid of the negative 1 here. It's multiplication, so I got to divide by a negative 1. So here's where I'm going to go. Ding, 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 because I'm dividing by a negative. Flip that thing and divide by negative 1. Ding, 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 flip that thing and divide by a negative 1. Okay, negative over negative is a positive. 5 over 1 is 5. Bring down my x. 3 divided by a negative 1 is a negative 3. Okay, so I'm going to go ahead and graph this. I've got my negative 3 over here. That's the lowest number. It's a open dot. Got my 5 over here. It's the higher number. It's a closed dot because it has the line equal to. That means it includes 5. Okay, and then since it's in between, all you do is graph it in between. Okay, you might see this one written as a negative 3 is less than x, which is less than or equal to 5. Both of those are the same thing. Right, so the solution set is all numbers between negative 3 and 5, including 5. Right, so we're going to take a look at this one. This is another AND. You've got two inequalities. When you're looking and you see two inequalities or you see the word or, then that means you're working with a compound inequality. So on the ones with the two inequalities, start in the middle. I've got a minus 7, so I'm going to add 7 to all three sides, the middle and the two sides. Okay, so a negative 7 and a positive 7 is a 0, less than or equal to 3/4 x, less than or equal to. A negative 4 and a positive 7 gives me a 3. All right, now I got to get rid of that fraction. Okay, so I'm going to multiply all of the pieces by a positive 4. I could have done that at the very beginning. All right, so I'm going to multiply this by 4, multiply this side by 4, and this side by 4. Okay, since I'm multiplying by a positive, I can just bring my inequality straight down. Okay, here 4 times 0 is 0. Here the 4's cancel out, and I just have a 3x left in the middle. 3 times 4 is 12. Okay, this is one way you can do it. You could also have them multiplied by the reciprocal. Some of you might have learned it that way. Now I've got to get rid of the 3. So I'm going to divide by 3. I'm not dividing by a negative, so I can just bring this down. I'm going to divide by 3. I'm dividing by a positive, so I just bring the inequality down. Only time you change the inequality or flip the inequality is when you divide or multiply by a negative. All right, so right here I got my x in the middle. That's what I want. Over here, 12 divided by 3 is 4. Over here, 0 divided by 3 is 0. So that would be my answer right there. It's my conjunction. Go ahead and graph it. 0 right there, and on 0, I get a solid dot. Put your 4 It's also a solid dot because it's less than or equal to. And since the X is in between, we shade all of the numbers in between 0 and 4. Okay, one more example of OR. You notice the OR is right there, so I know my answer is going to have an OR in it. Okay, if it starts with the OR, it's going to end up with an OR. All right, here we go. We're going to work this side first and add 1 to both sides. I get 2x is less than -9 and a +1. 9 minus 1 is 8. 9 is bigger, so I get a -8. Divided by 2, I'm just dividing by a positive, so the inequality comes straight down. I get x over here, -2 divided by, -8 divided by 2 is a -4. So that's one side. Come over here, add 15 to both sides. I get 3x is greater than or equal to 15. Divide by 3. Again, I'm just dividing by a positive, so it comes right on down. And I get x is greater than or equal to 5. Okay, so that's my answer. This is a disjunction. It's an OR statement. So I'm going to come over here. I'm going to go and put my 0 down. Got a -4 over here. Got a 5 on this side. Remember, ORs don't come together. So I've got an open dot on -4. So that guy's going to go this way, and it's all numbers less than. And then a closed dot on 5, and it's greater than, so it goes in that direction right there. Okay, something to always remember is disjunctions are never written as one statement. Those are your ORs. Okay, they will start out and end up as two separate inequalities with an OR in between. Ands are the ones that have two inequalities. Those are conjunctions.